Okay. What'd you go with? A, B, C, or D?
C.
I got some C's out there. Okay, let's talk about it. It says if an even degree polynomial, okay, so it's even, okay, has a positive leading coefficient. So not only is it even, it's positive. Now, even functions act like parabolas going up, up, or parabolas going what? Down, down. What they do in between, I don't know, but it's either down, down, or up, up. Well, because it's positive, you're picking what? Up, up, I hope. Right? So this would be what it's doing, up, up. Well, is it A? No. That's up, down. Is it B? Down, down. No. This is what? Up, up. That's what it looks like. And then this one is down, down, up. Okay, it's not this one. So it is C. The answer is C. Good? Okay, do 9. Do not look at this table though. All they want you to do is which of the following, right here, describe the end behavior of the function. All I want you to do is this. Give me the end behavior of this function. All you have to say is the word up, 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 down, whatever. Or you can draw me a picture. An arrow going up, an arrow going down. It's hard to read that up here, so I think I'm going to go to full screen. Okay, are you able to see it? Can you see what that is? X to the what?
9.
It is x to the 9th. Okay, is it positive or negative?
Negative.
Okay, so you should be thinking in your head, this is odd. Okay, the second you think odd, you should be thinking either it acts like a line going up or a line going down. Okay, well, what do you think it is? If it's negative, oh, by the way, I forgot to say, it's negative. You have a negative odd function. So you think it's a line going this way up or this way down? Okay, but I mean, it acts like a line going which direction?
Down.
Downhill. So on the left it goes up, on the right it goes down. So you should say up on the left, down on the right. That would be good. Or you could draw me a picture, up on the left, down on the right. And exactly what it does in between, oh, I have no idea. So I'll give you a couple squigglies. Okay. So there's the answer. Any questions? I think you probably knew that because of yesterday, but maybe I surprised you. Okay. All right, let's keep going. Okay, here it comes. This is what you did not finish on yesterday's homework, so finish it tonight. It is this. How many times will your function turn? Well, I'm going to give you something you already know. You know that is quadratic because it's x squared. Do you know what the graph is?
It's a U-shape.
It's a U-shape. It's called a parabola. Okay, it's either this or it's this. Anybody want to tell me which one x squared is?
Goes up.
The one that goes up because it's what?
Positive.
It's positive. Okay, so it's not this one. Okay, so here's my question. How many times does x squared turn?
1.
Do you agree it's 1? Look, I'm going to go downhill, 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 and then I turn and I go uphill. Okay, so the second you go down, 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 then up, you turn once. So a second degree polynomial will turn what? 1 time. So if second degree turns 1 time, any guesses on what a third degree will turn?
3 times. 2 times. 2.
You think it's 3 and you think it's 2. Well, here's 2. A second degree polynomial turns only once. So doesn't that seem like 1 less? A third degree will turn what? 1 less than 3. 2 turns. Okay, wait a minute. Now let's read this. The graph of a polynomial of degree what?
N.
N. They're not telling you the degree. They're saying N. It could be 3rd degree, it could be 8th degree, it could be 12th degree. Has at most, how many terms? How many terms? Hang on. 2nd degree had 1 term. 3rd degree has 2 terms.
So
Nth degree has what?
n minus 1.
N minus 1. So what's the rule when you want to know how many times a polynomial turns?
The exponent minus 1.
Take the what point?
The exponent.
The exponent. Okay, how about the highest exponent, the degree of the polynomial, whatever it is, minus 1. Okay, that's all you have to do. And then read the next part though, because the next part's pretty important. The graph could also have terms that are what? 2 less repeatedly from n minus 1. So here's what they're saying. Answer this question. How many turns does x to the 9th have? How many times can it turn?
8.
8. Okay, slash. The graph could also have terms that are 2 less than that number, 8. It could also turn what?
6 times.
6. Keep going.
4 times.
Keep going.
2 times.
Keep going.
0.
Okay, once you get to 0, then it doesn't turn at all. If it doesn't turn at all, you're done. Okay, so what does x to the 9th turn? At most. At most what?
8.
8. So guys, that's an important part of this. It could be at most 8 times it could turn, that's it. Then it could turn 6 or 4 or 2 or 0. You never know until you actually start graphing, but at the very most it's 8. Are you okay with that? So what if I gave you this one, x cubed turns what?
2 times.
2 turns at most. But what else could it turn?
0.
It could turn 0. Okay? Alright. That's-
So if it could only turn at most 1 time, would you just,
That would be a quadratic.
yeah, so you would just leave it
Oh,
at
yeah,
that?
okay, I see what you're saying. Let me just pick on an x. Yeah, you're saying like an x squared.
Yeah.
X squared can turn what?
1 time.
1 turn. Okay, subtract 2. Well, if you do subtract 2 from this, what do you get?
Negative 1.
And you can't turn negative times. So this is it.
Okay.
Once you get to negatives, you're done. Once you get to 0, now 0 is an answer because you can turn 0 times. Look, I've got one here for you. This one right here. Okay, this graph is what degree?
1.
1. So that means x to the first. So why doesn't x to the first turn? Because if you take the 1 and you subtract 1, what do you get?
0.
0. X to the first doesn't turn. You know why? Because it's linear, and linear is a line. Lines don't turn. Okay, this one is degree 2. How many times will x squared turn?
1 time.
1 time. I can subtract 2, but then I get to negatives. So look, 1 time. That's it. This is x to the what? 3rd. But an x to the 3rd function, I just did it right. Where did I do it? Right here. There's the answer. It can turn what?
2.
2 or
0.
none. Well, here's a none. Here's no turn at all. So to get a turn, guys, your graph has to go up, 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 and then what?
Down.
Down. Does this thing go down? No, it only goes up, 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 and it slows down. Never goes down, though. It slows down, then turns back and goes up fast. No turn. This one turns what?
2 times.
2 times. So x cubed can turn 2 times or none. Here it is. Here's your 2, and here's your 9. Just so you know. Just so you know what they could look like. Okay.
Wait, so 1 degree of 3 and the first one where it's turning?
Yep.
That is 0?
That's a 0. That's a 0. Watch. This is what's going on. The graph is going up, 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 up. Now it's kind of slowing down. It's still going up though. Then all of a sudden it just does what? It keeps going up.
Oh. Okay.
So for you to say in terms, it's got to do what?
Let's go
It
back
has
down.
to actually
It actually has to come down a little bit and then back up. How many turns do you see now? You should see 1 here and 1 here. Yeah. Come on.
Anybody?
Takes 3 of you to pick up all the pennies.
Yeah. Thank you for giving me my notes.
Where did you get them?
Yeah.
Did Coleman come through for you?
Yeah.
I was kind of doubting you.
I was running with like.
They're good. They're good? Okay.
Ooh. Did you?
Thank
Who-
you.
who-
Thank you.
All right.
Thanks.
Okay. Are you guys okay with the turns? Okay. I'll go on if you're okay. Okay. Next up. Oh, turns again. You said you're okay. This should take you 15 seconds. State the number of turns possible in this function, and down here, I drew a picture for you. Tell me the number of turns that it made, and then tell me the degree you think it is. What degree polynomial is it? It's honestly about a 15-second assignment. So I get it. Jonas, top equation on the left. How many turns can this one make?
5.
Okay, so I see this as it's in standard form. This is a 5th degree polynomial, right? Okay, how many turns can a 5th degree make? You said 5.
Oh, I added the other.
You have what?
I added the other x to it, so
Oh, yeah, don't do that. You have to look at it and go, this is x to the, this is in standard form, correct? It's not in factored form. So in standard form, this is, you just take that number 5, it's 5th. Now tell me how many times it could turn.
of 4.
And then, 2, then,
0.
yeah. So all you have to do is keep, just subtract 1, and then from there, just subtract 2. This is the most. That's at most. It can turn what? 4 times. Okay? How about this next one, Abenita? How many times can it turn? Once. And then if you subtract 2 from this, you get what? -1, and we can't turn -1 times. So guess what? That's it. It can turn once. That's it. All right, go down below. Tell me how many times this thing turns. Did you say a number?
3.
Okay, the number is, Claire says 3. Is she right? Follow my pen. Down, 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 down. I turn the corner, up. There's a turn. Up, 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 up. Turn the corner, down. There's a turn. Down, 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 down. Turn the corner, up. There's a turn. 1, 2, 3. Got it. 3 turns. Okay, and give me the degree it could come from. If I give you the number of turns, can you give me the degree of the polynomial? X to the 4th. Okay, it's a 4th degree. How come?
Turns 3 times.
Well, yeah.
4 minus 3.
If you knew you had a 4th, you subtract 1, you get 3, right? Okay, but wait a minute, just so you know this, that's the answer, but wait a minute. What about a 6th degree? Could it have been a 6th degree polynomial?
Yeah.
Because what does 6th degree polynomials do? They turn
5.
5 or
3.
3 or 1 or, that's it. And here's your 3. So it could be 6. It also could be what?
8.
8. Okay, it could be 10. But I'm not going to keep going like that, guys. This is all I'm concerned about. Give me what I call the least degree. Okay, give me the least degree and I'm happy. Okay, I don't need that. This is extra writing. Everybody okay? So if I look at a polynomial and it turns 9 times, what degree polynomial did it come from? What? 10. It's a 10th degree polynomial. Okay. If I know the number of terms, add 1, I get the degree of the polynomial. Okay, next up. Okay, factor theorem. I am not going to read this piece to you. Okay, I'm going to start right here. Multiple what? Zeros. Do you know what zeros are? I think you do. If you go back to the last unit, do you guys remember doing this? X minus 2 times x plus 3. When is it 0? Okay.
-3, 2.
So on the last quiz, when is x plus 3 0? When x is what? Yep, that's a 0. When is x minus 2 going to be 0? When x is 2. So you know what these are called? These are called what? Zeros of your polynomial. You found a 0, negative 3. You found a 0, 2. Okay? That's what they're called. But what's this? Multiple zeros. Well, listen to this. This is what it is. If a linear factor is repeated in the complete factored form of a polynomial, then the 0 related to that factor is a multiple of 0. So what they're saying is this. If you look at this factor and this factor and this factor, what are the zeros that come out of this one?
0.
Yep, this one will be 0. Okay. This one will be what?
Positive 3.
Positive 3. This one will be what?
Negative 1.
Negative 1. Okay. So you guys are pretty good at getting your zeros. Now, what's the multiple 0? It's how many times you actually see. How many times you really see this factor? Well, the only one that is more than once is right here. X minus 3 squared means what? X minus 3 times x minus 3. It happened twice. So if you look at this x and you go, oh, this one happened twice, then this one right here has a multiplicity, that's what they call it, of
0.
Of 2. So this 0 counts how many times?
2 times.
Twice. This 0 has a multiplicity of what?
1.
1 because it's x to the first. Sorry, this is getting really crunched. This 0 has a multiplicity of 1. It only happened once, so it's multiplicity of 1. So how do you know the multiplicity? You just look at the what? The exponent on the factor. Okay, that's it. Not going here, guys. Maximum, minimum, not going there. Okay, third page, or whatever you have to do. Okay, so here we go. Take a look at this. These are your zeros again. We're talking about that. The expression x minus a. I'm going to do this. X minus 5. I want you to see a number other than a letter. Okay. So the expression x minus 5 is a factor of a polynomial if and only if the value, not a, but what?
-5.
The value 5 is a what? 0. Because isn't 5 going to be a 0? X minus 5, what's the 0? 5. If and only if 5 is a 0 of the related polynomial function. So what they're trying to tell you is this. Okay? If I give you a 0, like 3, 3 comes from a factor. What factor did it come from?
X minus 3.
X minus 3. But what if I tell you negative 6 is a 0? What factor did that come from?
X plus 6.
Yeah. So what they're trying to say to you is this. If you know the zeros, you can write the factors, correct? Okay. All right. Would you just look at this one? If those are your factors, and this f of x is just simply 0, then what is your 0 out of this?
-1.
Your 0 is negative 1. Here your 0 is what? Negative 3. Here your 0 is what? Positive 2. Okay. Now I want you to look. Look at your zeros, and then look at your factors. If you know you have a 0 of negative 1, that goes with what kind of factor? X plus 1. So if somebody told me a 0, -1, how would I write the factor? I would just kind of change the sign from minus to what? Plus. Here it's -3, the 0. But what's the factor look like? +3. So you just switch the sign is all you do. Okay? All right. Now, here's where I'm going. What is a cubic polynomial function in standard form? Cross that out. That takes too much time. So give me a cubic polynomial in, let's say, factored form. Factored form, not standard. Okay? With zeros of -2, +3, and 5. Okay, so how do we do that? If you want factored form, here's your function, f of x equals, okay, now remember this is a 0, -2,
So it'd be x plus 2,
times,
x minus 3, and x minus 5.
yes or no?
Yes.
So if somebody tells me 0, 0, 0, I'm going to say, I know the factors of my polynomial. This times this times this is the polynomial that gives me those zeros. Yes? It's kind of nice. It's kind of nice when somebody does that for me. Okay? Can I turn?
Mm-hmm.
Okay. Okay. Oh, we're back to what? Multiplicity. I tried reading the first paragraph to period 1, and that just really didn't make a whole lot of sense. So I just quit. Okay, here's what you have to know. Basically the bottom stuff down there. I don't even think I'm going to read this to you. I'm going to just go down below, and this is what I want you to understand. Multiplicity of 1, multiplicity of 2, multiplicity of 3, and multiplicity of, what's next? 4. Would you write that down? Put a 4. Okay, how multiplicity affects the 0. Okay, first of all, multiplicity is this. Multiplicity of 1 is like when you say x minus 2, and if it's multiplicity of 1, the exponent appears 1. Multiplicity of 2 means what? X minus 2 to the what? Second. Multiplicity of 3. X minus 2 what? Cube. 4. X minus 2 what? Okay, so there you go. Okay, that's what it means. You just look at the exponent outside the factor. That's all it means. Okay, well, how does it affect the 0? Well, can somebody tell me what is the 0 out of this? The 0 is what? 2. You agree with that? Okay. But when I say the 0 is 2, do you know what I'm telling you? I'm telling you, when your x value is 2, what's your y value?
0.
Yeah, that's what a 0 is. What x value actually gives me 0? 2 gives me 0. So the x value is 2, the y value is 0. Okay. There's another thing I want you to know about zeros. They are actually on the graph, on your graph, they're basically your x what? They're your x-intercepts. So if you tell me 2 is a 0, I know it crosses the x-axis where? At 2. Okay, now let's fill this in. If the multiplicity is 1, in your own words, how does it affect the graph? Well, I would like you just to write this. If you have multiplicity of 1, your graph will cross the x-axis at 2. So let's make a picture of this. Graphically, what does this mean? It means this. At 2, your graph will come through, hit your 0, and continue on. So that is what multiplicity of 1 looks like. Okay? But if it's multiplicity of 2, it's going to do this. It's going to bounce. What does that mean? Well, I think you know what it means, but I'll just draw it anyways. Okay, so there's 1, there's 2. So here comes, your graph's coming in, and it's going to hit 2 and do what?
Bounce.
Bounce means it goes back down. Okay. But wait a minute, it could come from this direction, right? It could come from here. Multiplicity of 2 just means it bounces. So I don't know what it's going to do, guys. I just know it's coming from the left, and it's going to bounce off your 0. Okay, what would multiplicity of 3 do? Well, 1 is odd, 2 is even, 3 is odd. What's it going to do?
Cross.
It's going to cross. But how? Slow. So the higher the multiplicity, the slower it crosses. So what does this one look like? Well, let me draw you this one. 1, 2. So yes, it comes at the 0, but it crosses kind of slow. You see what happened? It does cross, it just crosses slower. And then guess what 4 does?
Bounces
Yes, you're right, it bounces, but
twice.
no, it bounces
Slow.
slow. So what's a slow bounce look like? Well, let's do this. That would be, here it comes. It's coming at 2, and it bounces slow. It kind of rides the x-axis for a while, and then it just goes down. That's a multiplicity of 4. That's a multiplicity of what? 2. Look at the difference between a 2 and a 4. 2 bounces quick, 4 bounces slow. What do you think a 5 would do?
Crosses. Slow.
Crosses even slower. What do you think a 6 would do?
Bounces.
Bounces slower. You know what I mean? Here, I'll draw you a 6. Watch, here's a 6. That's a 6. It just goes a little slower. But it still bounces. Okay? All right. Here we go. Identify the zeros, their multiplicity, and the effect on the graph. So, let's do this one together. Ready? See that factor? When is negative x going to be 0? Divide by negative 1, right? You get what? Okay. 0. Okay, what about the next factor? 3x minus 2. When is that going to be 0? Anybody?
2/3.
2/3. Add 2. Divide by 3. You get 2/3. And what about the last one? I can hardly read it. Is that an x plus 9?
Yeah.
Okay. When is x plus 9 0? That's an easy one. When x is what?
Negative 9.
Okay. The question becomes, what's the multiplicity? Well, you just look at the exponent. This is negative x to the what?
1.
First. 3x minus 2 to the
Second.
second. Okay. I can't read that. X plus 9 to the
Third.
third. Okay.
Oh,
Oh, that's a 5.
Is that a 5? Okay. 5. Gotcha. Okay. What's the effect? The effect on the graph is what they're saying. So if you know you have multiplicity of 1, you'll hit your 0 and you'll what?
Bounce.
Odd. Odd is bounce. Odd multiplicity bounces.
Oh, crosses.
Yeah, odd multiplicity crosses. Even multiplicity does what? Bounces. What's a 5 going to do?
cross slowly.
Cross slowly, yeah. And you could actually write very slow, but slowly is good. Okay. Good. All right. I found out last period I copied. This is not what you see. You guys don't see this. What do you guys see? You don't see my mess. You see something like
Maybe
X.
a plus
X what?
X to the third plus 10x squared plus 25.
Okay, so you see that. Okay, so give me the zeros. Give me the multiplicity. Give me the effect. You can't do it until you what? You got to get this look, this is standard form, into this look. What's this? Factored form. You have to factor. So guys, you can't tell me the zeros until you
Take factor.
don't wait for me. You guys should be well ahead of me. What are you doing to factor that? Please don't tell me your factoring skills have gone down that much. Come on.
You have to take it in X.
Take out the GCF. Take out an X. Gotcha. If you take out an X, you have X squared plus. Good? Now you look inside, you got a trinomial. You know trinomials can be factored into binomials, right? I know it's X times X. I need two numbers.
Okay.
Yeah, that multiply to give me 25, but add up to 10. Would you say 5 times 5 is 25? Would you say 5 plus 5 is 10? Yeah. Okay, look at your two factors, x plus 5, x plus 5. You could rewrite this as what? Right? Okay, now guys, when you write it like that, you know your multiplicity is what? 2. Okay. What are your zeros out of this? Your zeros are
0
0
and negative 5.
and negative 5. The multiplicity is what and what? That's 1. 0 has a multiplicity of 1. Negative 5 has a multiplicity of what? 2. And the effect on the graph is cross or bounds. At 0, you will cross the x-axis. At negative 5, because the multiplicity is 2, you're going to bounce. Okay? Good?
Isn't that backwards?
Do I have it backwards?
I think so. Because on the other one, you have it at 5 and it says it crosses slowly.
Well,
Oh, wait.
5, multiplicity when it's odd, Andrew, if your multiplicity is odd, it will cross.
Yeah, I see it.
Okay, look at this. That one's odd, 1 is odd, so it crosses, 2 is even, so it bounces. Okay, the higher the number, the cross and the bounce, that just slows down. That's all it does. Okay, can you read this one? It says a polynomial has a 0 at 4, multiplicity 3, and 0 is a 0, multiplicity 1. Write a function in, I don't like this, factored form. Okay, so here we go. My polynomial function, my polynomial function f of x is, if you have a 0 at 4, and you have a 0 at 0, tell me this, if your 0 is 0, where does that come from?
Oh, would there
Just
just be an X?
That's just x, yeah. X times. If your 0 is 4, what factor does that come from?
X minus 4.
Yes. See that, guys? So somebody tells me my 0 is 4. Well, that came from x minus 4. Somebody tells me my 0 is 0. Well, that just came from x. But the multiplicity is what for 4?
3.
3. So the 3 goes here. And what here?
1.
1. So there it is. There's my function. That's it. Kind of nice when somebody tells me my zeros. Okay? Then if I keep going, we do it again. But now we're not being told the zeros, we're given a graph. And here's the graph. Tell me, just by looking at your graph on your paper, what are the zeros on this one? So like to me, a 0 is whenever you put an x in and you get out 0. So would you guys agree that this point right here, right here, right here, okay, those are all zeros? Can you read these numbers at all? I think 7 is a 0. I think 1 is a 0. I think 4 is a 0. Correct me if I'm wrong, guys. I think -3 is. I can't tell this one. Is this a -6?
Yes.
Yeah. Okay. So guys, I have 1, 2, 3, 4, 5 zeros. You're supposed to write the equation in factored form. If I start with -6, what factor does that come from?
X plus 6.
Yep. Where does -3 come from? X plus 3. Where does 1 and 4 and 7 come from?
X minus 1.
Yep. X minus 4. X minus 7. Good? I just wrote the polynomial. The only problem is I did not look at the multiplicity. So let's look at multiplicity. At -6, did it cross or did it bounce?
Bounces.
It bounced. The multiplicity should be even. Did it bounce really slow or kind of quick? Boom, boom.
Quick.
Quick. I'd go with a 2. At -3, did it bounce or go through?
Bounced.
At -3?
It
I think it goes through. It crosses. But it goes through slowly. So I wouldn't go with a 1. I'd go with a 3. Because it went through kind of slow. Okay. And then at 1, what did it do? It crossed really quick. So I'd go with probably 1. At 4, it bounced, and it bounced pretty quick. So I go with 2. And at 7, what do you think?
bounced quick.
That looks like a 2. If you want to say 4 because you think it bounced slower, I'm not going to count that long. I just don't. I don't see any of those as really slow bounces. Here's a slow bounce, guys. A slow bounce would look like this. Hits your 0 about here, and then it comes down. That is pretty slow, isn't it? That would be multiplicity of 4 or 6. It's really hard to tell what it really is by looking, but just don't put an odd number when it bounces. Okay? Are you okay? Okay, all right, you seem okay. All right, relative mins, not going to talk about it. Okay, write the equation for the graph in factored form. We just did this, didn't we? Let's do it again. Is that all that's on here? Oh, okay. Let's just cross these 2 things up because they just skipped them, didn't they? All right.
We don't even have those.
You don't even have this?
We just have the graph, but not that down there.
Oh, well, can you put this? This is what you need to kind of understand. Okay, let's write down the word degree and behavior, zeros, and terms. Okay, write those 4 things down. Okay, we got 5 minutes. This is probably good enough. All right, you ready? Or not? Okay, when I say degree, all I care about is even or odd. Would you tell me degree? Is this even or is this odd?
Odd.
Down on the left, up on the right. So I guess I've already answered the end behavior, haven't I? The end behavior is down on the left, up on the right. Got it. Let's do degree. Okay, what's the degree of this thing? What?
3.
3. Why do you say 3?
Because there's 2 turns.
Okay, so number of turns, you counted 2. 1 is here, there's a turn, there's a turn. So these are called turns, right? So that's a turn, that's a turn. 2 turns, how do I get the degree? I add 1 to the turns. 1 turn, 2 turns, add 1, it's a what? It's third. It's a third degree. It's kind of then by name. By name, we call that cubic, just so you know. Okay. All right. What don't I know? I don't have my zeros. Tell me my zeros.
-2,
Okay. Yes.
0,
0
and 3.
and 3. Would you agree with those zeros, guys? Okay, guess what? I also want the multiplicity. So can you give me the multiplicity at -2? Did it cross or did it bounce?
Cross.
Cross. Multiplicity of 1. None of this crosses slowly. Okay, at 0, did it cross or bounce?
Cross.
Cross. Multiplicity.
1.
1. Remember, when it crosses, the multiplicity will be odd. And at 3, it crosses, right?
Yes.
So multiplicity is 1. Hey, guess what? You see these numbers? Look up, look up. If you add up the multiplicity, 1, 1, 1, you should get what?
3.
You should get your degree. And you do. We did it right. Okay, so this is what you're doing today on your assignment. Kind of right here. Okay, there it is. All right. Here's the deal. I told period 1 this too. So if you look at this, it basically says, give me the end behavior, give me the zeros, give me the multiplicity, give me the terms. It also talks about the leading coefficient, the leading term. So, you know what I never did with you? I never wrote the equation, but that's okay because you don't have to do it here. The leading term. Can somebody tell me what the, tell me what the leading term, they say term in your assignment. Is it positive or is it negative?
Positive.
How'd you know it's positive right away?
It goes down there.
Yeah, because it goes down on the left, up on the right. This gives it away right here. End behavior gives it away. Because you said down, up, it's positive. So when they say leading term, tell me positive or negative, okay? Hey guys, will you just try and get page 1? Now, what about yesterday's assignment? What do you got to do from yesterday?
List all possibilities for the number of terms.
Number of terms. So yeah, part D, right? Yeah, part D you have to do. Yes. So don't forget that. And then on here, just do page 1. And if you can't do page 1, I'm sorry. You're going to be behind when you walk in tomorrow. But I think tomorrow's a catch-up day. We got to kind of finish this notepad, right? All right.
Hi.
Oh, by the way, it's a late start tomorrow. Tomorrow?
Yeah.
I want to say 9:40. 9:45. Oh, yeah, it's about 9:45. Oh, yeah. Now, if you want to fill in your notes from yesterday, I put this on YouTube. So if you go Steve Payton, no space, Steve Payton. Get to YouTube, search my name, Steve Payton, and it will come up. Math model, polynomial. I think I even put March 12th. I'm gonna do the same. I just did your class right now. So I'll do day 2, polynomials, March 13th. But you're here, so you're okay. Did it make sense?
Yeah.
Yeah. Yeah, well, but here's the thing. Yesterday, what I was talking about was yesterday. Well, you know what? Now that I say that, there's other stuff. Okay. Hang on, I don't have an assignment for you. Okay, 1 second. I'm going to